Okay, so if we take a look at chapter 17, there's just the one objective, but it's got a lot in it because it says know how different stresses, change in volume, pressure, temperature, or the concentration of reactant or product will affect the equilibrium and amount of product or yield. So you've got, what is that, 5 different stresses, and you're supposed to predict if the equilibrium shifts left or right, and if that increases or decreases the yield as you do it. So an increase in volume, if we look at this particular equation here, if you increase volume, is that going to create more collisions or less collisions? Yeah, it decreases collisions. Let's do this. I'll come down so that we can see what's going on. The reason we know there'll be fewer collisions is because they're more spread out. So the collisions are going to decrease on both sides. But is one of these sides going to benefit more from the extra space? Yeah, the left side, the more crowded side will always benefit more from an increase in volume, and it will always see a greater change when you decrease the volume. So the change is going to affect the more crowded side more. So the more crowded side is the reactants. So if you decrease the collisions more on the reactant side, what do you form? More product or more reactant? More reactant. If you also slow down the collisions on the reactant side, the product is still chugging along, you're going to have more more reactant form. And we say the equilibrium shifts left because the reactant side is the left side. So we see an increase in the reactant. What if you increase the pressure in this system? What does that do to your collisions? Yeah, increased pressure will crowd things more, it'll increase collisions. I'm going to add that's more crowded in the container up here. There's more space in the container. That's the whole reaction. You don't get to just have the reactants on one side and the products on the other side. It's all one container. So if it's more crowded in the container, which side's going to see the bigger increase in collisions? The left side, the more crowded side, is still going to be affected more. So if you increase the collisions on the reactant side, more product forms. Because that's what happens when reactant collides. It forms product. So now your equilibrium shifts right. Okay, questions so far on volume and pressure? So it's not always the same. It's more about which side's more crowded. You have to look at the equation and see. Increase in temperature. Increasing temperature, again, it's always going to increase collisions. So the collisions are going to increase because there's more movement. And again, in the whole container. So there's more movement on both sides. But because delta H is a positive value, what do you know about this particular reaction? Try again. It's endothermic. Positive means when you put money in your checking account, that's a positive value. So something enters, En, that's endothermic. So if it's endothermic, does heat help the reactants more or the products more? If it's an endothermic equation, which the positive value tells us endothermic, does heat help the reactants more or the products more? It's reactants. It's reactants that benefit most from the heat. So there's more movement in the container on both sides, but the reaction is endothermic. So the reactants see the bigger increase. And again, if the reactants are colliding more, what do you form? Product. That's what it's all about. So more product forms, you're going to shift right. If this was exothermic, then it'd be the opposite. Then we'd see the greater increase on the product side and it'll shift left. So it's all about which side is affected more. Sometimes only one side's affected, but oftentimes both sides are affected. If you increase the amount of reactant, if it's a liquid, you could increase the concentration. If it's a solid, you could just add more grams of it. But if you increase the amount of reactant, how's that going to affect your collisions? Which collisions increase, Trevor? Yeah, the reactant. There's more reactant particles to collide. So guess what? More product forms. Equilibrium shifts right. So what happens if you remove the reactant instead? Just the opposite. You have less reactant particles to collide, so less product forms, and the equilibrium would shift left. If you increase the product, means there's more product particles to collide. And if product collides more, the more reactant's going to form, it's going to shift left. Generally speaking, an equation is written in the direction that you want product forming. So usually we're trying to increase yield. That's usually the focus. But occasionally you might want to increase the reactant for whatever reason.